Hello, everyone. Brief rundown of what we're going to go through. Each of these sections could probably be their own presentation on their own. But just starting off with an introduction, how projection mapping works, the general workflow that is used, the math and previs section, content creation, the software used, hardware used, and then we'll go into the demonstration right here. And then we'll have questions at the end. So brief introduction. These are questions I plan to cover in this. So what is projection mapping? How is it used on real world projects? How does it work? How does the system operate and how you can get started with it? All right, so here's some examples I pulled just to give a general idea of how it's used in the real world. So some of these are body projection mapping, where they use live tracking to project onto bodies of dancers. There's a lot of structure used for projection mapping, a lot of buildings. When Night Falls is a really famous one that's done in collaboration with Epson. Then you also have your corporate events like Samsung's 44th anniversary, and then also just in general, hacking and guerrilla projection mapping. So what is it? Projection mapping is just known as video mapping or spatial augmented reality. It's the use of turning a 3D object or structure into multiple surfaces and using those as specific projection surfaces to break it up and not just project in a flat 2D plane. So if you think about it, it's conceptually, it's going from just a flat illustration to a 3D model. So how does it work? Several steps, not a lot. You can break it down really simply, which I try to do as best as possible. But for a simple project, all you need is a media server or a computer, depending on what you have access to, as well as the software for the mapping on it, and then also the structure or object that you are projecting on for the project. That's really all you need. It's really simple to get done. It's just one of those things that as scale increases, so does the complexity and the needs of the software and hardware. This is just a general workflow for projection mapping. A lot of these are interchangeable in where they are in the process, but this is how I generally go through it. And so starting off, you have your conceptualization and design. So it depends on if you're doing this for a client, a class project, just for fun or for like activism. A lot of guerrilla projection used during COVID-19, like projecting the death toll that on buildings and stuff. But you also have your site inspection and analysis. So where is this at? Is this in a theater? Is this in a public space? Is this outside? You have to take into account all of these due to the limitations of projections. In a perfect world for projections, you're going to be in a black box, and the surfaces that you're projecting on are all going to be white, so that there's no color change in the surface. There's no color change in the projection. It's going to be as bright as possible, because at the end of the day, a projector is just a light that's emitting a variation of colors at once. So any other color, so if you're projecting on a red wall, that red is going to come out in all the animation and content that you create. And then after that, you'll go into projection math and previs. So projection math is where you're locating the projectors to make sure you have proper coverage on your surfaces. And then previs is piping in content to the software that you're using to make sure that the content matches up with the surfaces themselves before you go on site. Then you'll go into your projection system design. So once you know where you're putting the projectors, you can figure out what kind of projectors you need, the lumens needed for them. The higher the lumen count, which is the brightness of the projector, the higher the lumen count, the more expensive the projector is itself. Then you'll also have to deal with the structure of cabling, how you're sending the signal of the content from the server to the projector, and everything in between. And then step 2, you're going straight into content creation. So what are your needs for the project? Why are you making this project? How are you accomplishing that in all those formats? And you have your media server programming, which is how are you programming the actual software in the media server to projection map? And then you'll be mapping and calibrating beforehand, which goes hand in hand with previs. Like I said, these are interchangeable. It just depends on what your actual project is. And then finally is installation. So installing the system itself, all the projectors, all of the cabling, all of the computers, whatever you need in your system, setting that up. Then finally you're projecting it, and then you'll have to do mapping adjustments, because even if you have a model that you've built and pulled into it, it's never going to match the real world, because that model is going to be absolutely perfect and the real world is not. Even if you have something that is fabricated with machine like CNC and stuff, it's still going to be off by different tolerances. So you're always going to have to adjust. And then lastly, which is most important, and I always emphasize this, is documentation, because I mean, it's the point of everything. So like getting future jobs for your portfolio, proof of concepts, showing that you know how to do something. It's really important, cannot be emphasized enough. Cool. So projector math, not as scary as it sounds. A lot of softwares can do it automated for you, depending on how good you are at setting up your structure. Luckily, for me being in theater, a lot of theaters have 3D models built of their theaters. So this is actually the Brockett Black Box Theater in the Winship building. So this is actually the ground plan, which is on the left, which is the aerial view. And then on the right is called a section, which is just a slice on the side of it. And all of those different colors are the different projector beams from the projectors themselves. And this was modeled in Vectorworks. The whole point of this is to make sure you have proper coverage of your surfaces, because for instance, like this right here, if you aren't going over everything, then you're not hitting every side of the surface, right? So if you're off like right here, you have your physical limitation is right there. So you're not going to be able to bring this border up to the top here. And so you'll be SOL. A lot of projection mapping is preparation leads to success 100% of the time. So it's just really, really helpful. And also, depending on your scale of project, for instance, this show, which is Romeo y Juliet, I'm not actually rigging the projectors in the theater myself. So I have to give this documentation to the technical team that is rigging it. So I have to put the heights of the projectors, the side distances from projectors, everything in correlation with the grid system that's up there that holds the lights and the projectors, just so that whenever they hang it, it's in where I told them to, as close as possible, so that all the work I'm doing this prep is going to pay off in the end. Because if I don't provide that to them accurately, I'm going to screw myself over in the end, because then I'll have to redo everything essentially. So pre-visualization is after you've got your structure built, whatever you have. For instance, this is the set that we're using in Romeo and Juliet. And so if you saw, there's a million projectors. There's one on the floor, so we'll be projecting that floor pattern. So we'll be having that accurately on the tiles that it will be there. And then on the top, that whole set will also be mapped to as well. So all the individual columns, all of the trim of the staircase, the handrail, everything, that moon, that circle at the top. And then there'll also be an RP projector on that back screen as well. And you can kind of see it in the UV map right there. That is the coverage of our projectors and what area we'll be projecting in. So using this software, you can start testing all of your content and your content needs. You can get a better feel for what it's going to look like in the actual space. And it also helps with whoever your director is or your visual creator, have a cohesive team plan so that everyone's on the same page and you don't show up and show them something that you've been working on this entire time. And then they're like, that's not what we had talked about at all. So just really, really helpful. So content creation is a lot and could talk about it for days, but for projection mapping, the most important things are your raster size, making sure that you are encoding it properly. So if you need alpha, making sure you have like a HAP codec or Apple ProRes 444 with alpha. Sorry, that was a pull. But things like that, like if your content, you know for a fact is not, you need it to blend seamlessly and you don't want to just square whenever you're projecting. But a major key is knowing what your projector is outputting. For instance, this projector is outputting 1920 by 1080, which is standard for TVs, but for most projectors, they're actually outputting 1920 by 1200. So making sure whenever you're exporting your content is matching the projector that it's going to, because otherwise you're going to have an awkward time with a bunch of non-coverage, because that square that we were aiming for that whole time. And so it would be shorter whenever you export it, and then you're going to get it there and you're like, why is it not looking right? And that's because it's too short. Mapping software, there is a bajillion, but like I said, they're all different UI, workflow, and most importantly, cost. So just depending on your needs is what you're going to use, and also your preference and knowledge. Isadora and Touch Designer are just about the same. They're both node-based programming that also have other capabilities built into them. So I enjoy Touch Designer because there's a lot of generative things, and you can also pipe into like Disguise or another server. I mean, you can projection map with After Effects. I don't recommend it, but if you feel like pulling hair is still free. Green Hippo is another server-based one where it's proprietary and you have to use their server. That one isn't used in the industry a whole lot besides Disney and cruises. So if you want to do those two for the rest of your life, have fun with it, I guess. QLab, if you have you can get the free one, but you're limited to one display, I think, one or two displays. But if you have the license, you can get up to like 4, I think 3. And that one's really simple. But it's Mac only, so you can't use it on Windows. So that's another thing. Like watch out is Windows only. You can't use it on Mac. So they all have their own niches and reasons why, but all about the same, but all vastly different at the same time. Resolume is what a lot of VJs use. So if you ever go to a rave or concert, that's generally what the person using video is using. It's got live editing, stuff like that. So the hardware, like I said, really all you need is the server/computer, projector, the cabling, and like any dongles, adapters in general that you're going to get. But as I said, the bigger the scale, the more complex the setup gets, because I mean, this laptop only has one HDMI port, right? If you have a PC tower, that's depending on your GPU, you probably got one to 2 display ports, maybe 2 HDMIs. So you have to take into account like the amount that can handle, because you're outputting multiple different pieces of content at the same time streaming. So you're putting a strain on your graphics processing unit. One, it's going to get hot. Like you can already hear my laptop cooking. It's just been playing the same thing the whole time. So those are just some constraints for it. So really it's just you're fighting physics at that point, what your hardware can handle versus reality, essentially. Yeah. So this is a simple system diagram. This is for another show that's also happening next semester. This is just a 3 projector system. But so this is the PC and all the ports. So you have your mouse, keyboard. And so remember I was talking about cabling earlier, this is kind of what I mean. So we have these 3 HDMIs, and because HDMI cables can only go up to a certain foot, we use these HD-based TX like transmitters, like the TX on the same receiver. But we use those to transfer the signal to a CAT cable, which, if you know what those are, it's like a Ethernet cables, so that it can run a long distance. So it carries that data to this other receiver, which then receiver goes into a HDMI into the projector itself. So that's how a lot of cabling is done, because wired transmission is always going to be better than a wireless transmission. And then so we also have a monitor, so that's 4, and then this I guess 5. So there's no projection happening in that one. This one, however, you can see a little bit of the difference. Yeah, so this is the disguised server that I was talking about in the midway. So we can trace a little bit. Once again, this is for tech. Or board operated, so don't really have to concern yourself with those. But keyboard, mouse, monitor, and you have there's also just 3 projectors, the transmitters and receivers, and then we had a Mac Pro, like iMac, and a Mac running QLab, so that we have these 2 talking together. You can run keys through the skies, and sometimes we do, and we'll have it receive signal from the lighting board, so that when they trigger the queue, it triggers our queue at the same time. Like whatever their lights change, it'll change our content in time with them. And you can also have it set up where you're just clicking that as well. But we want to use QLab to make it easier for the board out during the show itself, because it's just simply a UI format where they're just hitting the space bar to go to the next, kind of like PowerPoint and with the simple. So that's why we have this port switch, which these are just ports for the Ethernet. You literally just plug it in, and that makes a LAN, like a local access network, instead of connecting over a Wi-Fi network. That's how they all talk to each other and signal to each other, computer to computer, and that's why it's so complex. You can see here, that's why we have it connected to the lighting network, but we also have it connected to the sound network as well, because they have their own separate boards in computers. So we want to I mean, in media, we really try to get as much signal from other people so that we can use that to our advantage as far as triggering content, changing content. Like if you wanted audio reactive, you're getting signal from the soundboard so you can manipulate and change the content itself in live time instead of basing it off of where we played that. Right.
Is there also a lighting system that goes on top of this?
Yeah, and that would be separate. So lighting has like those, like if you've ever been to a concert, they look like a big board and have like a bunch of sliders. So they look like a soundboard, same thing. They're just slightly different.
Can you give me an example of like the sound? You're saying you manipulate the sound rather than the sound?
Yeah, so they're just sending a live feed of the audio that they're currently playing. It's like essentially having a microphone and then
and then you're able to fade in, fade out, change it out.
Yeah. So we're using the data, the numbers that we're receiving from their sound waves to adjust our content. Yeah. Oh yeah, all the time. Yeah, it's so easy. It's the best. Yeah. Yeah, you can pull in actual tracks like pre-recorded MP3 files and stuff like that. You can pipe it in from live music. You can pipe in MIDI from like Ableton, for instance, as well, if you want like live DJ effects as well. Yeah, it's really that easy. Yeah, once you get everything to your computer, then like the world's your oyster. That's just the hardest part, is making sure you're getting. Yeah, demonstration time. Don't be overwhelmed. This is it right here. This is the simple area, as I like to call it. This is like the furthest area. That's as far as like you can take it. So you have your performance window in your project folder. So this is how I did the mapping to the cube right here. This is where all the content's stored. And this is just a system to make it easier to map itself. So that is the one drawback of Touch Designer, is that there are some nodes, like the stoner is how I'm actually mapping this one right here. So if you look, it's just these little points that you can like drag. Ooh, oh, I'm blinding myself. That was an awful idea. Yeah, so it's really hard. It's really hard with the content. So like I was saying, most programs have it pre-built in, but you'll use a test pattern. I like to use a checkerboard because you have even lines going X and Y essentially. This method is eyeballing. I don't have a UV model that I'm putting this to. This is just, like I said, this is like the just running gun way. So if I reset this, that's what it looks like. That's projection. You start moving these things around, you have two panels. This is projection mapping. It's mapping. Yeah. Yeah. Yeah.
Projection.
Yeah. This is like, for instance, for this exact instance, where it's not a complicated model. First of all, it's just two faces, right? There's not facets or anything. There's no curves that I have to be concerned with. It's just two flat planar faces that I just want to be mapping onto instead of just blowing it up everywhere. Oh, this is a terrible idea. I should have waited to do that till the end. But anyways, it doesn't command Z. Not in this window. Just because it has a lot going on. Yeah, I did.
It's such a fail.
So for the content itself, obviously a little more complicated. So it all starts right here. This is the node that is receiving the data from the Connect itself. Yeah. Then I'm using these right here to pull out the background a little bit more so it's not getting as much noise. It's going in here to this, which is a geometry. So this is how I'm turning it into a 3D model instead of just 2D. And it's a point cloud system. If you know what that is, it's just like what it sounds like is points making up a cloud, which are in the shape of a 3D object. Up here, this is where we're getting our color from. Woohoo! And then we have our camera. So this is just like a regular 3D model. So we need a camera and a light to light the scene and to visualize the scene. And it's going into the render. I'm flipping it to mirror the image so that it makes sense because it was backwards. So there's a delay. I didn't realize that. But it was flipped. So I just did this and I'm going to flip it back. And then all of this data. So we have our colors format coming into here. So for this project, it was, this was originally a Fusebox Festival exhibit that we had during their like after hours. So it was like a cocktail hour, and this was shown at two of the three spaces. The first one being the Museum of Human Achievement. So it was on their indoors thing, so people could come up and play with it. And then it was at Ani's Day and Night. And then it was projected on the outside corner of the house. And on that one, we actually used two Kinects to cover more space to get more data. And so for that, all four of these are the different like brushes or different looks. And so I'm using this network right here to change which yeah, the like paint, the paint, yeah, the paint look. And then all those green ones are just a time code essentially to make sure that the brushes change like every 60 seconds. Just that way so that people would keep interacting with it because you don't want the same thing to just be sitting up there the entire time. So if we come in here, this is what the brushes look like. So we're pulling in the stuff from out there.
Are the brushes like didn't you just drag and drop them like different brushes?
No, these are all built. These are all built. Yeah, so these are pulling the stuff in that was out here. So all of these that are coming into it are going in here. They're coming back here. So you have your Connect again. This is where we got a color. This is the camera data that was rendered out. And then this is just a simple feedback loop. So feedback is like whenever you have a camera pointed at the monitor, you know, it has like a delay effect to it and it's kind of multiplying. And then that's how we get this color and fun. And woo, this is what it's outputting. The motion is coming from the feedback. So it's like actively layering itself. Yeah. Yeah, so we have this feedback right here. So these are coming in. So this is like our movement of the body. So that's what's being tracked. But then we have this right here, which is just this right here. So if you see this LFO, that's it's just giving it a slight change. So LFO is just going back and forth. Essentially, it's just like constant change in numbers. That's all it is. That's what it does. It's like a 0.1 frequency at the 360 amplitude. And it's just ramping. So if you see this little dotted line, that's where you can trace where it's going. So it's not actually connected to these. It's right here. So this number, this hue offset's being referenced, is referencing that LFO. So that's why you see, like as this goes up, this is changing. And then we're replicating that change in here. And you can see it's just layering itself and layering itself. So like if I turn this feedback off, nothing. So like you're just getting that hue change on the Connect camera essentially, right? So like we have this right here. Ooh. Look at it go. And then that's essentially how all of these are built, is just different changes. It's like this one, we added a noise for fun to get more visual effects. So that's why it's got more of like a scatter to it. Yeah, and then just pulling it all into this switch, which that's it's referencing, once again, those numbers, so that it's just constantly changing. And that's all there is to that. Yeah, this is like super complicated. I would say, what is your goal?
Figure out what your goal is in YouTube projects.
Yeah. I like, if you just want to do something simple where you're playing a video instead of doing something generative like this.
Okay.
QLab.
I would say two.
QLab is essentially you drag in your content,
Okay.
you hit play, and it gets output to either your monitor or to the projector you're using, right? And then it literally just has this, the system right here, it has this built into it. And it's a million times more simple.
I'm seeing some projects people do that I honestly don't know. Projection mapping.
It's limitless, essentially. You know, you're just constrained by what hardware you have access to and what software you have access to.
Yeah. What's the benefit in using like a high system for the geometry in this? It's really just square.
The benefit is for the content, not for the projection mapping. So we're taking this this point cloud data, right? Because we have all of these options. We have color, depth, IR, and player index. Player index is just a grayscale mapping of players, essentially. So it's just changing the difference between the background and the profile of the player.
I stress about what AJ just said on the goal idea, because I feel like that's something you guys need to connect your software skills to. Is you are just doing software skills to do software skills, but like you should do it with purpose. Like, oh, I wanna project on a square window. What software skills do I learn? One day, you know, what do I need to do to take those steps? So when you go see the Immersive Showcase audience students, so you know, look at what they're doing and be like, how do I get there? And then you have to do it. Think people. Okay.
Thank you.